Hi everyone, welcome back. This is another video on the same topic, element and the periodic table. So this is part 4. We have already covered in the other videos, part 1, part 2, up part 3. So today we're going to look at we're going to continue from where we stop in part 3. So the success criteria that we're going to um, cover by the end of this lesson are as follows. We're supposed to discuss with specific examples the patterns in physical as well as chemical properties of group 1 elements. So let us start. So remember we started looking at other um, properties of group 1 element. So we're going to continue with the property number 7. So the property number 7, there we covered almost 6 properties. So we'll continue from there. They have the ability to impact color of flame. So what does this mean? Usually it means when you bend them, they will be able to show different colors. So the property of alkali metal is used in identification of the alkali metals. So using the different colors which shows when they bend in oxygen, you'll be able to tell that this one is potassium, this one is lithium, this one is this one is sodium. So let us go into a diagram. So here we have a physical property, flame color. When you bend them, then you check. So this is lithium. It produces crimson lead. So crimson lead is this one. Then sodium, it shows yellow. So this is the yellow flame. Then potassium shows pale violet. So this is pale violet. While rubidium shows violet. So this is violet. Then we have caesium. It shows bluish. So the bluish color is this one. So that's property depending on flame. So group 1 elements have also the characteristics of being ductile as well as malleable. So it's also another physical property of group 1 element. They have characteristics of being ductile and malleable. So these are two words where we need to look into details about them properly. So we'll start looking at ductility. So what is ductility? They can be drawn into wires. How is that possible? So because their atoms within this metal structure are arranged in layers. We can buy it maybe, for example, if you were to draw the structure of solid, you find that solids have particles which are arranged in layers. So because of those layers, the same applies to ductility of metals. Their atoms are arranged in layers, usually in fixed position. So those layers can be stretched. So if you stretch the layers, you can form a long wire. That's why we're saying that they can be drawn into wire. Ductility simply means they can be drawn into wire. Another one is malleable. Malleable, they can be hammered into any shape. For example, we can use the metals to use a pot. We can use the metal to make maybe aircraft parts. We can use the metal to make a lot of things. So the characteristics, what makes them to be drawn into different shapes? We'll still use the same knowledge. This is done when the force is applied in the metal where the layers slide over each other. So when you are hammering it, you are sliding the layers in a metal, and you can bend it and form different shapes. So it's very important why we discuss about this ductility, because we usually use metals in each and every day, and most of the time we are puzzled that we find different shapes of metals. So it's because of these characteristics. We can conclude that because they have atoms arranged in layers, so those layers can be stretched, or they can be, you can apply a lot of force, the layers can slide and can change into different shapes. So The table below gives a summary of all physical properties of alkali metals, which are group 1 elements. So we have talked a lot about the group 1 elements. So here we have elements, we have lithium, we have sodium, we have potassium. Here in this column we have symbol, we have lithium, we have symbol of sodium, symbol of potassium. The physical property or the physical states of matter at room temperature. We have all of them, they are going to be found in solid state. Their colors, they are silver in color, metals throughout. Sodium, lithium, as well as potassium, their color is the same. The melting point, we discussed about the melting point. They have different melting point. The first one, which is lithium, has higher melting point. As we are going down the group, the melting point is decreasing. We also tackled why the melting and boiling point decreases as we are going down the group. We said as we are going down the group, they form a weak metallic bond. Therefore, it can be easily heated. Can change state of matter to another state of matter. In terms of electric conductivity, all of them, they are able to conduct electricity. That's why here we are saying that they are good conductor of electricity as well as heat. So now we'll shift from physical property, we'll start looking at the chemical properties. In chemical properties, usually we focus on the reaction which they can undergo. So the first one is that they react with air, or can I say they react with oxygen to form oxides. So alkali metals react with oxygen to form metal oxides. When alkali metals react with oxygen, for example, if we may use lithium, lithium may react with the oxygen to form lithium oxide, which is a mono oxide. Mono means you are going to have one oxygen molecule in that particular compound that is going to be formed. And another one, we can use sodium. Sodium can react with oxygen to form sodium peroxide. So sodium peroxide, the chemical formula is this one. And potassium metal can also react with oxygen to form potassium peroxide as well as potassium oxide. So you might check that now the product which is going to be formed is different from one another. Here we have monoxide, here we have the peroxides. And we said as we are going down the group of group 1 element, we said the nuclear charge is decreasing, and that one helps to know which metal is more reactive. Remember, we said for the metals to know which one is more reactive depends on how easy they release the valence of valence electrons. So the product which is going to be formed when they react with oxygen depend now on the amount as well as availability of oxygen used. That's why they are able to form different compounds. So these metal oxides are generally solid in nature. So let us start looking at one chemical reaction that is with one metal. Lithium being the least reactive alkali metal react with oxygen to form simple oxide. So we can have an equation, lithium react with oxygen to form simple oxide. We can have a word equation first. Lithium is combining with oxygen to form lithium oxide. So this is a chemical equation with symbols. So the color is silver and the product is white. So when we're talking about lithium oxide, this is the chemical formula of lithium oxide. Sodium can also react with the oxygen and produce a simple sodium oxide as well as sodium peroxide. So the chemical formula of peroxide, an ion of peroxide, is this one. We have subscript 2 and superscript 2. So sodium react with oxygen and form sodium oxide. So these are the chemical equation on how we can represent the reaction and the product. So this is a simple oxide that is formed, but we said it can also form peroxide. So the chemical formula of peroxide is this one. When you combine oxygen with enough oxygen, when you combine sodium with enough oxygen, we expect to produce sodium peroxide. So this is the chemical formula of sodium peroxide, and the color is yellow-white color. Potassium does the same, react with oxygen to form simple oxides as well as peroxide. So at first, when potassium reacts with oxygen, it forms potassium oxide, which is white in color. Can also react with potassium can also react with oxygen, enough oxygen to produce sodium peroxide, which is also white in color. So in this particular chemical property, we have said they react with oxygen or air to produce either a simple oxide or peroxide, depending on the amount of oxygen which is available. Note, now we need to be very careful here. Note, so there are some realization. The reason why different types of oxides are formed when alkali metals react with oxygen. This has to do with the stability of oxide that is being formed in solid state. When we are talking about stability, it means we are looking at if it is stable and can form a stable structure. Since all the oxides formed are ionic compound, what do we mean when we're saying ionic compound? An ionic compound is a compound that is formed when a metal combines with a nonmetal. So their stability depends on how strongly their cations and anions attract to one another. Remember, in the ionic compound, we've said we have metal and nonmetal. So when we are talking about cation, a metal becomes a cation because it loses these valence electrons, which are going to be gained by nonmetal. When a nonmetal gains the valence electrons, becomes an ion. So the stability depends on how these strongly attract to one another. So lithium usually forms a predominant lithium oxide. It means does not the stable compound of lithium will be lithium oxide, not lithium peroxide. Because of this, the compound is more stable than lithium peroxide. And we can buy the same idea to O. It means sodium and the potassium can form either potassium oxide and the sodium oxide, or potassium peroxide or sodium peroxide. Those all compounds are stable and at room temperature and can be formed depending on the amount of oxygen used. Now this is a gas jar with a deflagrating spoon showing how the group 1 element or the alkali metal burn in oxygen. So if you put it here, since oxygen support combustion, will be able to burn with flame. So the flame, you can be able to tell that this one is lithium, sodium, maybe, or potassium. So alkali metal, the second one, alkali metal react with water to form hydroxide as well as hydrogen gas. The reaction is so vigorous in nature such that when you're handling it, you need to be very careful. Lithium is the only alkali metal that reacts slowly with water. Why? It is less reactive. What makes lithium to be less reactive? Remember, we said reactivity in metals depend on how easy they release the valence electron. So since lithium has small atomic radius, we expect that the valence electrons are strongly attracted to the nucleus, hence cannot release it easily. That one makes lithium to be less reactive. So it reacts slowly because of that reason. It does not melt because the reaction produces less heat, which is not sufficient to melt it. Lithium hydroxide solution is formed from the reaction. It's an alkali solution. It changes the color of an indicator to show the presence of alkaline solution. So depending on the indicator used, it will be able to show different colors. So lithium plus water, if we are to use the equation, we have lithium hydroxide and hydrogen gas. So this one is a chemical equation illustrating what happens in the word equation. So sodium react vigorously. If you can check, it is the reactivity increases as we are going down the group. So sodium react vigorously with water than lithium. So sodium plus water to be sodium hydroxide plus hydrogen gas. So this is the chemical formula for the reaction, the chemical equation for the reaction. Potassium react explosively. So you can check the words, the adjectives that we have used to explain the reaction. Here it is more vigorous, here it is more explosive. It means this potassium is the one which reacts more quickly with water. Why is like that? Because potassium is the most reactive alkali metal. So when they react with water, they're going to produce sodium hydroxide, which is a basic solution, and hydrogen gas. Not when all group 1 elements react with water, they produce a basic solution. A basic solution and hydrogen gas. When you test that solution using different indicators, you're going to be able to see different colors based on the indicator used. So here we have a diagram which is illustrating the nature of the reaction when group 1 element react with water. So here it means the lithium was dropped here. If you can see, it is able to show small bubbles, which shows that the reaction is taking place. But if you check on the sodium, you see that the bubbles now, the number of bubbles is increasing, which tells you that now the reaction is more vigorous. But here, check, even if it is there, you can see that just putting it there are many bubbles, and it is able to burn. It is able to produce some spills, which tells us that the reaction is more explosive since potassium is most reactive. So color change of different indicators when added or dipped in an alkaline solution, which is formed when group 1 elements react with water. So if you use litmus paper, the color will change always to blue. If you are using bromomethyl blue, the color will be red. If you are using an universal indicator, the color will be purple. If you are using methyl orange, the color will be yellow. If you are using phenolphthalein indicator, the color will be pink in the solution, the basic solution that is formed. Alkali metals react with chlorine to form chlorides, salts. So lithium may react with chlorine to form lithium chloride, which is white solid. The equation is this one. We have lithium, we have chlorine here to form lithium chloride. Same applies to sodium. We have sodium reacting with chlorine and to produce sodium chloride, which is still white solid. Potassium may also react with chlorine to form potassium chloride, which is also white solid. So you can check here, we have potassium chloride, potassium plus chlorine to form potassium chloride. This is the chemical equation. Alkali metal react with alkanols. Apart from chlorine, so it can also react with alkanols to produce a metal alkoxide and hydrogen gas, similar to what was happening when it is reacting with water. So when lithium reacts with ethanol, it produces lithium ethoxide plus hydrogen gas. So the chemical formula of lithium ethoxide is this one. This is one, lithium ethoxide. So we have lithium plus ethanol to produce lithium ethoxide plus hydrogen gas. Same applies to sodium. When sodium and ethanol react, sodium ethoxide is going to be formed and hydrogen gas. So you just remove one hydrogen which was there and replace with hydrogen sodium. Same applies with potassium. So for potassium may also react with ethanol to produce potassium ethoxide and hydrogen gas as stipulated in the equation here. Alkali metals react with acid to form salts and hydrogen gas. So they can also react with acid to form salt and hydrogen gas. For example, lithium may react with hydrochloric acid to produce lithium chloride and hydrogen gas. So we have lithium plus hydrochloric acid to produce lithium chloride and hydrogen gas. Same applies with sodium as well as potassium. They will also produce either sodium chloride or potassium chloride and hydrogen gas when they react with an acid like hydrochloric acid. So all these can be stipulated in the equations here. This is the equation for lithium, this is the equation for sodium, and here we have the equation for potassium. So all what we have said here, we can verify it using an experiment. It can be done in the lab. But we can also do other experiment to check if the metal that you are given is an alkali metal. Sometimes when you work through in the lab, you might find that there are many metals, but sometimes people forget to label them. So you have some specific experiments that you can carry out to check if the metal is group 1 element. So you can still use the reaction that we have discussed so far to check if the metal that we have found is belong to group number 1. So from now we'll be looking at the experiment. Later on, maybe in the other videos, we'll be able to conduct the experiment thoroughly so that you should be able to see the results if they are concurring with what we have written in our descriptive experiment. So when we are describing an experiment, we still need a lot of steps. So we need an aim, we need the apparatus or materials, we need the procedure, we need the results and observation and conclusion. So our aim is to investigate the physical appearance of alkali metal. We want to know the appearance of alkali metal. The apparatus that we need a white tile, we need a pair of tongs, we need lithium metal, sodium metal, potassium metal, and a knife. The procedure: using a pair of tongs, hold a piece of lithium metal and place it in a white tile. Using a knife, cut a piece of lithium metal to expose it. Since it's soft, it's exposed inside. Record the observation. Repeat steps A to D using sodium metal as well as potassium metal. The results and observations: all group 1 elements are soft, such that when you cut, it is easily cut by a knife. When freshly cut, they look shiny inside and silvery, but its shiny and silvery disappear after some time. Conclusion: group 1 elements are easily cut by a knife because they are soft and it shows shiny and silvery appearance when freshly cut. Their shiny and silvery appearance after some time disappear because they are very reactive and they can react with air. So this is an experiment that can be carried out, and this one is how you can describe it to check if the metal is a group 1 element. Experiment number 2 that we can use in order to check or verify if the element is group 1 element. So we'll still use the same procedure. We need to have an aim, we need to have apparatus, we need to have procedures, we need to have results and observations, we need to have a conclusion. So in terms of an aim, is still the same: to investigate the reactivity of series, the reactivity of group 1 elements or group 1 metals. The apparatus and materials that we need distilled water, we need a petri dish, we need lithium metal, we need sodium metal, we need potassium metal. So in procedure, but first of all, we need to measure 5 mils of distilled water and put it in a petri dish. Put a piece of potassium metal in a petri dish with water. Observe the reaction. Repeat the steps A to C with lithium and sodium metals. So observation and results: what do we expect or what you can obtain? The reaction of potassium with water will be more explosive, followed by the reaction of sodium with water, and the last one will be the reaction with the lithium and water, which will be less vigorous. This shows that potassium is the most reactive, seconded by sodium metal, and lithium is the least reactive. So reactivity of group 1 elements known as alkali metals increases as we are going down the group, such that potassium will be the most reactive, followed by sodium, then the last one is lithium. We can also say that the reactivity of group 1 elements increases moving down the group. Conclusion. In conclusion, the reactivity of group 1 elements increases as we are going down the group due to increase in atomic radius. Therefore, the valence electrons are weakly held and can be easily released during chemical reaction. Experiment number 3. The aim of experiment number 3 is to investigate the type of solution formed when group 1 element react with water. The apparatus that we need distilled water, we need lithium metal, sodium metal, potassium metal, litmus paper, as well as a beaker. Procedure: measure 10 ml of water and put it in a beaker. Put a piece of lithium in a beaker of water. After the reaction has completed, dip a piece of litmus paper in the solution. Observe the color change on the piece of litmus paper. Repeat the steps A to D with sodium and potassium. So the results that we need to expect if that one happens, or the solution in all the solutions. So for example, if you are going to make a solution where lithium is going to react with water, sodium is going to react with water, as well as potassium is going to react with water. If you dip the litmus paper, so all the solutions from the metals shows a blue and violet color when a blue litmus paper is dipped. In conclusion, when group 1 elements react with water, they produce a basic solution. Why are we using the word basic? Basic because they are able to turn any color of litmus paper into blue. So here we have a buzz session, a quick exercise where we need just to follow up and check what we have covered so far. The first one will be explain why potassium is more reactive than sodium. Explain why magnesium is less reactive than sodium. When alkali metal react with water, they produce very violent reaction. Explain that. Write the balanced chemical equation of the reaction between sodium. So here we have a follow-up question. This is just information, but the question is here. When alkali metal react with water, they produce very violent reaction. This is the information. Now the question: write the balanced chemical equation of the reaction between water and sodium. Explain the order of reactivity of alkali metals. Question 5, complete the equation. So we have part of the chemical equation here. You need to write the products if this one can combine with this one. Then here we have, we need to provide the reactants if the products are these ones. Explain why the activity of metal increase moving down the group. That is question number 6. Question number 7, why are alkali metals the most reactive metals on the periodic table? Number 8, why are alkali metals ductile, malleable, as well as good conductor of heat and electricity? And here we have an experiment that we need to describe. A newly discovered element X is suspected to be a group 1 metal on the periodic table. Describe an experiment you can carry out to verify this supposition. So that marks the end of our presentation. If you need a tool to check match, we have used the following materials. We have used Excel and Succeed, Junior Chemistry Book 2, Achievers in Chemistry Book 2, Target in Junior Chemistry Book 2. On the photos that we have used in our presentation, these are the links where you can click and check more. So if you have at all problems in the what we have presented, as well as maybe you have more questions, please try to find us and follow us on Xulendo.org where you can be assisted. This marks the end of the presentation.